Right, hi. I'm going to go through how to calculate the empirical formula. Basically, I'm going to go through 4 steps to calculate the empirical formula for a molecule. Remembering that the empirical formula is the simplest ratio of atoms found in a molecule. It is different to the molecular formula, but it says the molecular formula is the same as the empirical formula after being multiplied by a ratio. So here are the 4 steps I'm going to do, and here's the question I'm going to answer. So the first thing to note here is that they've given me some information about what the actual compound is I'm talking about, or the molecule. They've said here that it contains a compound that has 36.84% nitrogen and 63.16% oxygen. So we want to know what the actual ratio is of the atoms in that molecule, and we can calculate that by finding the mole ratio. Now, in order to find the mole ratio, the first step we really want to do is have an idea of the moles of each of the atoms. So we're going to find the moles by taking the mass divided by the molar mass. Now, in this case, this is a percentage mass, but it doesn't matter. We won't get it won't be a true mole value that it will give us, but it will give us a ratio, which is why over here I've called this the mole ratio. So I'm going to put nitrogen here, and I'm going to put oxygen here, and so I'll write the values down for them. 36.84, that's percent, and 63.16%. So this is percentage mass, and I'm going to divide that by the molar mass, which is for nitrogen is 14, and oxygen 16. Okay, so I carried out that calculation, and remember what I'm getting here is a mole ratio, or the moles. I'm going to get the answer here of 2.63. And this one here is going to give me the answer of 3.95. Okay, so this is these numbers here, these two here, are starting to give me an indication of that there's more of the oxygen and less of the nitrogen. But I want to know specifically how much more, get a specific ratio. To further simplify this, what we do now is we don't have a whole number. So as step 2, we are going to divide our smallest, our mole ratios by the smallest mole ratio number we attained, and in this case that was 2.63. Now when I divide the 2.63 by 2.63, of course I'm going to get 1 because it's the same numerator as a denominator, and when I divide the other one I get 1.5. Now this isn't a whole number ratio, so we're going to have to do step 3. Now step 3 says if it's not a whole number ratio, multiply it by the smallest whole number we need to get a whole number ratio. So what I do is I multiply both of these by 2, and I get a whole number ratio of 2 to 3. And so I could have put all this into my table. I'm not going to bother about doing that at the moment. The ratio of 2 to 3, 2 nitrogens to 3 oxygens, is then written as N2O3. And that's the empirical formula. Okay, I'm just going to pop through and do another couple of examples of this really quick. So we're going to go through the same steps here. So here's the first one. So I've got potassium. Well, let's just go through how I did this before. So potassium, 42.39. I've got iron, 15.22. Carbon, 19.57. And nitrogen is 22.83. Divide this through by molar mass of potassium, which is 39.1. Molar mass for iron, 55.8, molar mass for carbon, 12.0, and nitrogen, 14.0. answer. So this is my, remember again, this is my percentage mass, this is my mass, and this is my molar mass. Sorry, wrong way around. Percentage mass, molar mass, and moles. It's just moles. And so we're going to get 1.08, 0.27, and 1.63 and 1.63. Now, this is not a whole number ratio. We have to simplify this. Now, it's almost always we have to simplify it. We go through, we find the smallest number, that's 0.07, and we divide everything by 0.27, sorry, not 0.07, 0.27. And then the ratio we get here is 4 to 1 to 6 to 6. So these are whole numbers, and we just use these to write our empirical formula now. So we get K4 Fe 1, don't have to put a number down, carbon 6, nitrogen 6. That's my empirical formula. Okay, here's another example here. So we've got sodium, Na, sulfur, and oxygen. We got 2.91 grams of sodium, 4.05 grams of sulfur, and 3.04 grams. Now notice this stage we actually have the mass. Now it doesn't matter whether we start with the percentage mass or the mass, we do the calculations exactly the same and it will give us the same result. Okay, so we're going to divide this by 23.0, which is the molar mass for sodium, 32.1 molar mass for sulfur, and 16.0 the molar mass for oxygen. I'm going to then get the moles for each of these, which gives me in turn 0.127, 0.127, and 0.190. Again, find the smallest number of these. That's 1.27. Oh, sorry, 0.127. Need to start getting my decimal place correct when I'm calling this out. Okay, 0.127, and I come up with my ratio 1 to 1 to 1.5. But these aren't whole numbers. We've got a 1.5 here, so I have to multiply everything by 2 to get them to a whole number. So I get 2 to 2 to 3. This is my mole ratio of sodium to sulfur to oxygen. So I'm going to have Na2S2O3, sodium thiosulfate. Done. And that's how we work out empirical formula. Thanks for watching, and just look out for the next video where I'm going to show how to calculate the molecular formula from the empirical formula.